Subscribe to our YouTube channel, Joy Learning TV.
Hello viewers, welcome to Junior High School R on Joy Learning. I am Miss Boama Sarah, your facilitator for Integrated Science. Today, we will be looking at diversity of matter, element, compound, and mixtures. By the end of the lesson, I will expect you to be able to define an element, compound, and mixtures. Write the symbols of some of the elements. By the end of the lesson, you should be able to define an element, compound, and mixtures. Write the symbols for some of the elements. Good. Let's quickly do a short test. What do you remember? In 5 minutes, answer the questions on the screen. We have 4 questions there. We're going to take it one after the other. We take the first one. What happens to a piece of stone if you keep hitting it with a hammer? What happens to a piece of stone if you keep hitting it with a piece of hammer, or if you keep hitting it with a hammer? Let's quickly put it down. Let's see how best we can explain this. I hope most of you have seen stone, and you have also seen a hammer before. You have a hammer in hand, and you keep hitting the hammer on a piece of stone. What happens to that piece of stone? You have a piece of stone and a hammer. You keep hitting the stone with the hammer. What do you think will happen to the stone? You have a piece of stone and a hammer. Now, let's see what will happen to the piece of stone as you keep hitting it with a hammer. Good. Now, let's get to the second question. What happens to water if you spray it from a sprayer? What happens to water if you spray it from a sprayer? We have all come across a sprayer. You have water in there, and as you spray, what happens to the water? Very good. Now let's get to the third question. What happens to a table salt when dissolved in water? What happens to a table salt when dissolved in water? We have all seen table salt. We use them in cooking, or we use it for cooking, for seasoning our food, and for preserving our food. You collect a small piece of table salt, dissolve in water. What happens to the salt? We all use salt in our various homes for cooking, for preserving our food, and for seasoning our food. You have a small piece of salt put in water. What happens to the salt? Good. Now let's get to the fourth question. What do these things help you to understand that matter is made up of particles? Or the three questions we have asked. What do you think will help us to understand that matter is made up of particles? We take some few minutes as we try and put our answers down. Let's take the first one again for those who did not have the opportunity of writing. What happens to a piece of stone if you keep hitting it with a hammer? If you don't have a hammer, and probably you have any strong object, as you hit that object on that piece of stone, what happens to the stone? Now, what happens to water if you spray from a sprayer? Apart from water, there are other liquids that are kept in containers or spraying cans. As you spray, what happens to those liquid or the water in there? Now, the third question. What happens to table salt when dissolved in water? Very good. Let's quickly look at some of the expected answers. I know with that of the stone, most of you would have written the size of the stone will reduce. Very good. That is a good work. The size of the stone reduces until it turns into a smaller particle or particles. Hope you had that one right. Good. With the second one, or the second question, the water comes out in smaller size. As you spray the water from the sprayer, the water spreads and comes out in smaller sizes or in smaller particles. Sometimes you have a drop. If you bring your hand or the body closer. With the salt, I hope by now you've all had it right. There is no way you will see the salt in the water. It will dissolve and form a uniform solution. Or it will dissolve and form a uniform mixture. Apart from the salt, we can also use sugar. When you have tea, porridge, or any other liquid substance, and you put in sugar, as you stir, it dissolves to give you a uniform mixture. Now, what do you say about matter being made up of particles? Matter includes all materials or substance in the universe. In this universe, we have matter making up all the substance. Some form of matter can be seen and touched. Yes, I know you know some of these substances I'm talking about. Let's take water, stone, salt, wood, and soil. All these are substances that can be seen and touched. Let's see if we can get 2 more examples. Kindly pick your pen and your notebooks and write 2 more examples in there. Good. I know you have table there, you have chairs there, you have books there. That is very, very good. If you had missed that one, don't worry. As we go along, you will get more examples that will help you to give other examples. Some form of matter, such as air, cannot be seen or touched. You can only see these particles with the naked eye when it is in a large quantity or when there is a lot put together. We always feel the air around us, but we can't touch it. We can see it with our naked eyes too. Then, let's ask ourselves these questions. What may matter contain? What may matter contain? Once we are looking at substances that are in smaller particles, definitely matter may contain 2 or more different kinds of particles. Matter may contain 2 or more different kinds of what? Particles. Let's get an example here. Rusted iron. It contains particles of rust. Can we get any other examples too? Good. We can get other examples too. If a material contains particles of only one kind, then we can say that that material is called an element. When we have a material containing only one kind of particles, we say that material is called an element. Good. Let's look at a Greek philosopher. He was known as Democritus. What did he do? He had talked about atoms many years ago and believed that if he divided a substance into smaller parts, then divided each substance again and again and again, he will finally reach a point where that substance can no longer or can not be further divided. Let's take this stone and the piece of hammer that we had talked about when we started the lesson. Most of you gave us the size of the stone will reduce. Now you keep on hitting, you keep on hitting, you keep on hitting. A time will come, the particles that we are going to obtain will be difficult to be broken down. We can combine all these ideas to explain what an element is. Don't forget, we had said earlier on that matter may contain particles of 2 or more different kinds. We gave rusted iron as an example, being a material that contains particles of rust. We said that if we have a material that contains only one kind of substance or particle, it is known as what? An element. What is an element? Let's see if we can define an element in our own words, bringing all the ideas we have got so far. Very good. Now, let's look at what an element is. Let's try our best to see if we can explain an element in our own way using the ideas we have gotten so far. Let's have this mind as we try explaining our element. From the Greek philosopher Democritus, an atom that is being broken down, further down, reaches a point whereby it can no longer be divided. It will now contain only one particle. I hope you are making a good headway. Good. Now let's look at what an element is. It is a simple chemical substance that consists of only one kind. A simple chemical substance that consists of only one kind. An element cannot be broken down into any simpler substance. So you bear with me. Democritus was right by saying, as you keep on dividing it again and again and again, it gets to a point it cannot be divided again. An element is a pure substance. Let's take it again. An element is a simple chemical substance that consists of only one kind. An element cannot be broken down into any simpler substance. An element is a pure substance. Then the question is, how many elements are there? How many elements are there? Currently, modern scientists has discovered a lot of elements. About 118 elements. These elements we are talking of, they are all natural elements. Some occur naturally in combination with other elements. Some of the elements are occurring naturally in combination with other elements. So if you are not careful, you might think they are other substances, but no, they are elements. Let's look at some of the examples of these elements that we are talking about. We have gold. Gold is very common in this part of our country. Let's see, where do we mine this gold? In our country, we have Obuasi gold mines, we have Tarkwa and other places. What do we use the gold for? Let's see if we can get 3 uses of this element gold. Very good. I can see you have earring there, watches, necklace, and other beautiful jewelries we use to decorate the body. Another example of one common element is aluminium. This element too is very common in our country. What do we use this aluminium for? Making of saucepans, roofing sheets, and other things. We also have oxygen as an element and hydrogen. How many examples have we mentioned so far? 4. Gold, aluminium, oxygen, and hydrogen. These are just few. Remember, we said scientists have discovered about 180 elements. As we go along, we will be introduced to the other forms of elements. What are compounds and mixtures? We take compounds. Let's see if we can put something down in an attempt of explaining what a compound is. Good. I know you have there putting something together to make it quite big. Not bad. Let's look at what a compound is. Many substances are made up of atoms of 2 or more elements joined together Many substances are made up of atoms of two or more elements joined together. We are looking at atoms of two or more elements. So we have one element making up atom of only one kind, another element making an atom of only one kind. The two elements comes together to form what is known as a compound. I am taking it again. Many substances are made of atoms of two or more elements joined together. These are called compounds. Let's look at examples of these compounds. We have carbon dioxide. Carbon dioxide. Carbon dioxide is a compound. Why are we saying it is a compound? It is a compound because we have two elements coming together. Let's try and see if we can get the elements coming together to form the compound carbon dioxide. We have the element carbon, we have the elements carbon and oxygen. I hope you can see what has been underlined on the screen. We have carbon and we have oxygen. These two elements do come together to give us the compound carbon dioxide. Now another example. Water. 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 Two elements comes together to give us water. We have the first one, hydrogen. We have the first one, hydrogen. And the second one, oxygen. So a hydrogen atom and an oxygen atom comes together to give us the compound water. I hope that one is understood. Let's quickly go back to that slide again. We are looking at compounds where we have two or more elements coming together. We gave two examples, water and carbon dioxide. Let's try and see if we can get two more examples in our notebooks. Good. I hope you have it there. Sugar is a compound. Sugar is a compound. We have two or more elements in there. Now we look at mixtures. Mixtures. When we close from school and we get home, sometimes in the course of trying to find something to eat, we quickly have to put something together so we could eat. Mommy do cook for us, putting two things or 2 or 4 ingredients together to prepare something for us. At the end of the day, it comes out perfectly. When we say mixtures, we are looking at any material that consists of 2 or more compounds. Any material that consists of 2 or more compounds, chemically combined or simply mixed together. Let's take that of the food. You go home in the afternoon, you got hold of water, then you quickly add milk or any other thing to prepare a shake. Water is a compound. The milk is a compound because it contains other elements. You bring the two together and a mixture has been formed. Let's look at some of the examples of these mixtures. We have air. Air, the air that blows around us. The air that we feel, the one that we breathe, is a mixture of gases. Air is a mixture of gases. We have oxygen in there, we have nitrogen in there, and other gases. All these coming together to give us a mixture. Brass. Brass is also a compound because it is made up of a mixture of copper and zinc. Back again to the lunch. We have sugar, we have gari, we have water. This is very common. You put the 3 together and a perfect mixture is formed. Can you quickly think of any mixture? Good. We have tea. We have soup. We have the paste we use for brushing our teeth. We have drinks, beverages, a lot. Now let's quickly look at some of the chemical symbols for these elements. As I said earlier on, we have 118 elements that modern scientists has discovered. All these elements has been represented with letters. All these elements individually is being represented with a letter. These letters are known as symbols. These letters are known as symbols. These letters we are talking about was proposed by a Swedish scientist. Then you think he might thought, the elements are too much and that. Why not get letters to represent them? These letters that are known as symbols. was accepted nationwide by all scientists. And the symbol of an element is the shorthand notation of its name. I'm taking it again. A Swedish scientist proposed letters which is known as symbols to represent elements. These letters was accepted nationwide by all scientists. And these symbols were shorthand notation of the names of what? The elements. For some elements, the first letter of the English name of the element was used as the symbol. Remember, I said the symbol of an element is the shorthand notation of its name. And so, for some elements, the first letter of the English name of the element is used as the symbol. It is always written with a capital letter. It is always written with a capital letter. So let's take the element carbon. That is the English name. Once there is an English name, then it means probably there might be other languages that are element has been coded. We are looking at carbon. From what we said just now, we are saying that it is always written with a capital letter with the first letter of the English name being used as the symbol for that element. So when you take carbon as an element, the first letter is C, and the C should be written in capital letter. For element which begins with the same letter, two letters are used as the symbol, but only the first letter is capitalized. Pay critical attention to this particular sentence or point. For element which begins with the same letter, two letters are used as the symbol, but only the first letter is capitalized. Good. Now, sometimes the symbols are taken from the Latin name for the element. Remember, we said some of the elements derive their names from the first letter of the English name. Now, some of the elements sometimes also do take their names from the Latin names of that element. Let's take an example. Kali. Kali is the Latin name for potassium. Kali is the Latin name for potassium. The chemical symbol for potassium is K. So definitely, one may wonder why potassium having P-O-T-A-S-S-I-U-M. P-O being the first two letters, but the chemical symbol is K. We are having the K as the letter representing the element because it has been derived from the Latin name Kali. Another example, gold. Two letters have been used to represent the element gold. We have capital A and U. The Latin name for gold is aurum, A-U-R-U-M. So, if you see the chemical symbol for gold being AU, please do not get confused. The first two letters have been used, and it has been used based on the Latin name aurum. As we go along, you are going to meet more elements and their symbols. What have we learned so far? All materials are made up of matter. Matter is made up of tiny particles called atom. An element is a substance that contains atoms of only one kind. There are about 118 elements being discovered by scientists. Each element has a symbol which is used by all scientists all over the world to represent the element. Let's pick our pens and notebooks and try out this. Let's draw up a table with 3 columns: headed, element, compound, and mixtures. Very good. We have some substance here. We have water, carbon dioxide, air, gold, aluminium, and sulfur. With these 6 substances, let's see if we can place them in the correct column. What was the column? We have elements, compounds, and mixtures. Let's see if we can place these substances in their right column. Now let's see if we can think about things we find in our classrooms and add more substance to each column. For the sake of those who just joined, we are looking at element, compound, and mixtures. We have seen what an element is, being an atom of only one kind, a pure substance, and a substance that can no longer be divided further. We have also seen a compound. We said compounds are chemical combination of two or more elements. We gave examples of compounds. We have water, we have carbon dioxide, we have sugar, we have a lot. Mention them. Now mixtures. When we put these compounds together, a mixture is formed. Let's see if we really understand what we have done so far. Draw up a table with 3 columns: headed, elements, compounds, and mixtures. We have 6 substances there. We have water, we have carbon dioxide, we have air, gold, aluminium, and sulfur. Let's place these substances in their right column. Look around in your classroom and see if you can add more examples to it. Good. Let's quickly check our answers. With the 6 substances that was given, with element, compound, and mixtures, we have gold under elements, we have sulfur, we have aluminium. Hope you had it right. That is very good. If you had it wrong, don't worry. We are going to have more examples that will make it more clearer. Now, under compounds, we have water and carbon dioxide. Hope you had that one too. Then under mixtures, we have air. That is a very good work done. Keep it up. As we go along, we will meet a lot of examples that will make our lesson or our understanding very broad. Thank you for enjoying the lesson. Bye-bye.
Joy Learning TV.